Hello, welcome to CCNA1 Introduction to Networks. This is going to be Lesson 1, Introduction to Network Devices. So, today we're just going to go over different network devices and what they do. So, just adjust this here. Okay. Alright, so Lesson 1, CCNA1 Introduction to Networks, Network Devices. So, what is a network? Well, Wikipedia describes a network as a computer network is a digital telecommunications network which allows nodes to share resources. So, what is a node? Well, to better understand this term, we can introduce different types of network nodes. So, we can introduce the basic ones, which are clients and servers. So, if you look on the left there, that's a server. And a server, as its name implies, provides functions or services for clients. It serves data to clients that request it, and that's all a server does. So, a client is the opposite of a server. It accesses things that come from the server. So, a client, sometimes referred to as a host or an endpoint. A client can be anything from a laptop, a desktop PC, a phone, or anything. It is some type of destination, and the end user doesn't even necessarily need to use it. It can be something like a factory machine or anything like that, IoT devices, what have you. For the purposes of networking, we can define a client as a device that accesses a service made available by a server. So what's important to understand is that clients and servers can really be anything. What the word client doesn't necessarily imply a phone or a PC or a laptop, and a server doesn't necessarily have to be a 24-inch rack server like a Dell PowerEdge 1950. It can be anything. So all you really need to do to meet the definition of a client is to request something. So as you can see here, give me image.jpg. You can see PC1 is the client, and then PC2 sends the image.jpg over, and PC2 is acting as a server. So this demonstrates that you can be a PC and still act as a client or a server. All this word describes is the interaction between the two. So let's move on. Let's move on to the cloud. So the cloud is really just an abstraction, and it's a general term used to describe the internet. It doesn't represent a real physical network device, but it's something to understand, like our ownership of our network. So in the real world, we can understand things like the point of demarcation and all this stuff, but all it really means is that the cloud is really just like your ISP and stuff like that, like the outside internet. It's something that's outside of your control. So in other words, it's the part of the network the cloud represents is not necessary to understand the network that you're focusing on. So that's the outside world, right? Like YouTube, you have to go through the cloud to access the YouTube server, right? So that's all this is. So let's move on to routers and switches. So switches are typically PCs and servers don't connect directly to each other. I know I said that they can, but they typically don't, especially in an enterprise connection. Imagine how many wires you would need. So so typically these connections are often aggregated to a device called a switch. So I don't know if we got this term from telephone networking companies when you would talk to the switch operator, but all a switch is it has a lot of ports on it. So you can take like a Cisco Catalyst 2960 switch, has like 24 ports, I believe, on it, Ethernet ports. That's really all a switch is. It has a lot of interfaces you can connect endpoints to, or hosts, computers, whatever you want to call them. So switches forward traffic within the LAN. Within, that's a very important distinction. So we're going to move on to routers on the right. So as far as routers go, they primarily communicate with the cloud and other routers. So this means that routers communicate between networks. So they go between networks, not really inside the network. I mean, it does some of it, but So that's what a router looks like on the right. So that's a diagram. So let's move on. This is a local area network that I set up in a Cisco packet tracer. You'll have the download link in the description if you want to use this program. We'll learn how to use it later on in the lab. But basically you see here there's a switch and two PCs that are connected to each other. That's a local area network. So PC 0 and PC 1 are both in the same local area network, or LAN, L-A-N. And let's consider the various properties of switches. So switches have many network interfaces or ports, Ethernet ports or whatever. They provide connectivity to hosts within the same LAN, and they do not provide connectivity between LANs or over the internet. So you don't use switches to access the internet. So let's move on. This is a wide area network, as you can see, the cloud there in the middle. So these routers communicate over the cloud to each other. So this switch 0, PC 0, PC 1 is one network, and they go to router 0. Then they can go out to the cloud. If they want to reach PC 3, for example, it's going to have to go through router 0, through the cloud, through router 1. It's going to have to go through the switch 1, and then it can reach PC 3, for example. So that's really all you need to know about wide area networks. You can call this a wide area network. It establishes connections between large geographical areas, typically. The word large geographical area can mean anything from, like, across the country or across the world, or it could just mean like a very large area of land, like on your business. Some businesses have like 24 acres of land, something like that. That could also be considered a wide area network if you have routers. So let's discuss more properties of the router. So routers have fewer network interfaces than switches. They're used to provide connectivity between LANs and are therefore used to send data over the internet. Okay, so let's talk about firewalls. This is another network device. So a firewall, well, first off, let's consider the scenario that a malicious actor is attempting to hack our data, hack our servers, and steal our information, deface our websites, all that sort of stuff. So what do? Well, that's where a firewall comes in. So the purpose of a firewall, it's a network security device that controls network traffic entering and exiting your network. So as you may learn later, firewalls can police inside the local area network as well. They don't necessarily just sit on the outside and be the gatekeeper, so to speak. But you'll learn that later. So in either case, a firewall can be placed either inside or outside at the edge of the network, and the device on the edge of the network is typically called the edge router. So the purpose of the firewall protects the local area network from emerging threats, hacks, things like that, viruses, malware, hackers, and brute forcing, all that sort of stuff, all that bad stuff. So firewalls must be configured with security rules and policies to determine which network traffic should be allowed and which should be denied. And that's a very basic overview. You'll find that firewalls have many more features. We can talk about some of those later on in the course, especially if you take CCNA security and especially if you take Palo Alto. But right now we're just doing a basic overview. So let's talk about different types of firewalls. There's many different types of firewalls. You're probably already familiar with a software firewall, which is like what's on your PC, like Windows Defender. Well, not Windows Defender, but Windows Firewall. And you'll notice that you can like block certain applications from going out the network, things like that. So there are network engineers typically deal with hardware, physical firewalls, so you carry and mount on a rack that you can touch and plug things into and stuff like that. So these kinds of firewalls, there's Gen 1, 2, 3, and 4, which are packet filters, stateful firewalls. There's stateless firewalls, application level gateways, and next generation firewalls. Primarily, you're going to be focusing on next generation firewalls because those are the newest toys right now. So that's the latest and greatest in our technology. So that's probably what you're going to learn. There's other benefits and downsides to using the other firewalls, but next generation usually combines all the best features of the previous generations and tries to mitigate the downsides. So that's why we use those. So they have features like deep packet inspection and data loss prevention. We can talk more about that in CCNA security, but let's just review some of the basics of firewalls so far. So firewalls monitor and control network traffic based on the configured rules. They can be placed inside or outside the network, and there's different types. So there's software firewalls, classic firewalls, next generation firewalls, etc., etc. So let's consider a network. Oh, actually, I guess I didn't put that in. Well, thank you. Thanks for watching, and I'll see you in the next video. Yeah. Oops.